So the idea with this is exactly the same as what we had before. So remember what's going on here is we're assuming that we're going to end up we want to do a confidence interval for pi. We want to be able to estimate a proportion with a confidence interval. But we haven't taken our sample yet. And so the question is, if we want to have some certain margin of error, how many people do we need to sample or talk to or get to take surveys or something so that we get the margin of error that we want? Right? So like if you were going to do a political poll, and at the bottom of your poll results, you wanted to say margin of error plus or minus 3 percentage points. So you know you want to have a margin of error plus or minus 3 percentage points. How many people should you survey to make that happen? So these are the kind of calculations people who actually do polling might do. Or theirs might be a little bit more complicated, but a similar idea. Okay? So what you can do is exactly the same thing as I did before. So in the last little video, I derived the formula for n. It's the same idea here, and you end up with this. A z-critical value divided by the margin of error squared times p sub est and 1 minus p sub est. Okay? Because remember, the sample proportion showed up in the formula, but you don't know what the sample proportion is going to be until you actually take your sample. So what we have to estimate here is this, estimate the proportion. Estimate the proportion. That's what we have to do. So in order to get the p sub est, there's a few things we could do, and most of these are similar to what we had last time. You could use an educated guess. So if you, for some reason, you think you know what the proportion is in your group, go for it. You could look and see what people have done previously, what previous research suggests. You could use a pilot study. The nice thing about dealing with proportions is there is a quote-unquote most conservative choice. That means if you have no idea what you should use as the proportion, you're never going to have a higher sample size than if you use p sub est equal to 0.5. Why is that? Well, let me show you why. I got to give you your daily dose of algebra, so here you go.
Thank you.
This is the formula, right? This says n is equal to p sub est times 1 minus p sub est times this stuff. What do you know about this stuff? The z-critical value comes from where? It comes from the table. So it's a number, comes off of a table. The margin of error comes from where? You get to choose it. So are you going to know this number?
Yes.
Are you going to know this number? You take a known number, divide by another known number, and then you square it. You just get a number, right? It's going to be positive, isn't it? Okay. So you're going to get some positive number. In math, they might call that a positive constant, right? So really, you've just got something that looks like this. You've got, we'll just call this thing C, some constant. So you've got p sub est times 1 minus p sub est times a positive constant. You guys buy that? So what values can this p sub est take on? Proportions can only be between 0 and 1, right? You can't have a negative proportion, you can't have a proportion bigger than 1. So proportions are going to be between 0 and 1. What happens to this function when p sub est ranges from 0 to 1? Does anybody remember back to an algebra class? What happens if you have x times 1 minus x times some constant? We can kind of ignore this constant. What happens if you have x times 1 minus x? What type of graph is that? I'm sorry, go ahead. What did you say? Carl?
Linear.
No, it's not a line. X times 1 minus x is not a line. It's a parabola. X times 1 minus x is a parabola. So it's going to be a parabola. So here's 0, and here's 1. And this is the p sub est axis. And here's the n axis, if you will. Right? Because n is kind of if you think back to algebra, n is playing the role of y, and this piece of EST is playing the role of x. That's what's going on. So we've got a parabola. There's a lot of different ways to graph a parabola. This is in factored form, if you remember back to some algebra class you took somewhere. When it's in factored form, it's really easy to figure out what the intercepts are, right? What are the intercepts going to be? 0 and 1. So this thing's going to cross right here, and it's going to cross right here. So remember, parabolas, one of these things that looks like this, or could be this. Does ours open down, or does it open up? Down. Because it's going to have a negative term. When you take piece of EST times negative PST, you get negative piece of EST squared. So it's going to have a negative out front. It's going to open down. And so another fact about parabolas, if you look at the x-intercepts or the intercepts, the vertex, remember the point at which it turns around, has to be halfway in between those. So it opens downward, and so it's going to be something like this. So let's see if I can draw this. Maybe something like that. Why do I not continue with the parabola down that way? Because piece of EST can't be negative, and it can't be bigger than 1. So this is literally the entire curve. Now the vertex would be right here, halfway in between, at 0.5, like that. Now the height of this thing is going to depend on C. But the shape is always going to look like this. Carl, you had your hand up.
I think the reason he thought that it was going upward is because he learned that the parabola opens upward and when it's positive.
Yeah, I was thinking.
But it's not positive.
It's not positive. Though.
Yeah, because it's got a negative right here. When you take piece of EST times negative PST, you get a negative PST squared times C.
That's kind of what I was thinking.
Yeah. All right, so what we want to do is think about when is n going to be the biggest? What value of piece of EST is going to be the biggest n?
The vertex.
It's this vertex right here. So when piece of EST is 0.5, n will never be any bigger, will it? So that's why, right here, I say if you have no idea what to choose, if you have no idea what the proportion is, if you just pick piece of EST equal 0.5, that's going to give you that highest n. It's like you're kind of covering your bases, if you will. That's why I call it the most conservative choice. Okay? Does that make sense? You guys okay with your daily dose of algebra?
That was enough. Yeah.
Okay, that was enough? All right. Yeah, so if in a problem, if I say use the most conservative choice, that just means plug in 0.5. Because if you're never going to do it, you're never going to have any bigger sample size, no matter any other proportion you would choose. All right, so look at a couple of examples here. A researcher wants to estimate the proportion of voters who will vote for candidate A. This candidate A is popular in my notes. She wants to estimate to within 0.05 with 90% confidence. So 90% confidence, that just means we're going to do a 90% confidence interval. That's going to give us the critical value, right? When it says we want to estimate to within 0.05, we want to estimate the proportion to within 0.05. What am I giving you there? I'm not giving you a piece of EST. I'm giving you the margin of error, right? You want to estimate to within this way or this way. So what's the margin of error for this one? 0.05, plus or minus 5 percentage points. But we want to use the 0.05. So do this on a different piece of paper, maybe. So number one, how large of a sample does she need if she thinks the true proportion is 0.9? So if she already has some a priori notion I think I wrote this in a different order than I had the notes there. The same thing. So I'll take the z critical value, divide by the margin of error, square it, and multiply that by piece of EST times 1 minus piece of EST, right? If we're doing 90% confidence, what is the z critical value going to be? 1.6449. The margin of error we said was what? 0.05. The piece of EST? 0.9. So if we think if she has some notion, we'll just use it. So it's 0.9 times 0.1. So we plug that in our calculator. So 97.41. What would I do with that number? Round up to 98. So you need 98 people in that case. Number 2, how large of a sample does she need if she thinks the true proportion is about 0.6? So what's going to change here? Yeah, the only thing that's going to change is, so we're still going to have the same critical value, we're still going to have the same margin of error. These are going to change. So instead of multiplying by 0.9 then 0.1, it's going to be 0.6 then 0.4, right?
Why would it be 4?
Because 1 minus 0.6 is 0.4.
Oh.
Does that make sense?
Yeah.
So you get 259.75. And so maybe we should round that up to 260 people. And then for number 3, all right, maybe we don't know what it is, so let's use the most conservative estimate. The most conservative estimate, the only thing that's going to change is what? Use 0.5 as the piece of EST. So I'll take 0.5 times 0.5, because the complement of 0.5 is 0.5. And when I plug that in the calculator, 270.57. So maybe round it up to 271. Any questions on that? So you notice the closer your proportion is to the middle, the higher the sample size is. And remember that parabola kind of shows that as well.